Imagine waking up tomorrow to discover you've entirely lost connection to space. No GPS to guide you, no satellite internet, no live weather tracking to warn you of storms. This sudden, global blackout wouldn't be the result of a war or an alien interference. It would happen because humanity accidentally built an invisible prison around our own planet. Right now, there are more than 10,000 active satellites silently orbiting above our heads. They are the unseen gears keeping airplanes safe, powering financial systems, and connecting continents. Our entire modern civilization is balanced on a fragile, invisible network that we rarely stop to think about. And that reliance makes us deeply vulnerable, because hidden right alongside those working satellites is another population. Millions of pieces of abandoned rockets, dead spacecraft, and shattered metal fragments. This is Earth's orbit, where every single object is traveling at nearly 28,000 kilometers per hour. To put that into perspective, that is faster than a rifle bullet. At those extreme speeds, a piece of debris doesn't need to be massive to cause a disaster. A stray screw or a tiny flake of paint becomes a lethal weapon capable of completely destroying a spacecraft on impact. We have built our most critical global infrastructure inside a high-speed, unpoliced shooting gallery. It's a landscape where our most essential tools are constantly in the path of incoming fire. The math behind this danger was first mapped out in 1978. A NASA scientist named Donald J. Kessler looked at the growing number of satellite launches and noticed something deeply unsettling. He realized a single collision between two objects in space wouldn't simply break them. The impact shatters both spacecraft, instantly creating thousands of high-speed fragments. These fragments strike other satellites, triggering an endless, self-sustaining loop of destruction. Scientists gave this perpetual motion machine of destruction a specific name: the Kessler Syndrome. While it sounded like science fiction in the late 70s, the mathematics hold up. Today, it is considered the single greatest long-term threat to human access to space, and the chain reaction has already started on a small scale. In the year 2007, China tested an anti-satellite missile, intentionally destroying one of its very own weather satellites. Instantly, thousands of pieces of large debris were generated, many of which are still up there. Just 2 years later, a dead Russian satellite collided with an active American communications satellite. It was the first time two intact spacecraft accidentally crashed into each other at hypervelocity. That single impact multiplied the danger, adding thousands of high-speed projectiles to an increasingly crowded environment. These two events proved the Kessler Syndrome was already in motion. The debris from just these two collisions will continue to cross through busy satellite paths for the foreseeable future. This chart compares the kinetic energy of an object in orbit versus an object on Earth. As you can see, in space, a metal fragment just 1 centimeter wide carries the same kinetic energy as a detonating hand grenade. And the terrifying part is that these lethal microfragments are completely invisible to Earth's radar. Spacecraft have zero warning before an impact. Now, companies are launching mega constellations containing thousands of new satellites to provide global internet access. While the benefits are huge, this dramatically increases our orbital traffic. The consequences are happening now. The International Space Station, along with other critical satellites, is frequently forced to perform emergency dodging maneuvers. This orbital highway has no brakes and no police. With thousands of new launches every year, we are rapidly pushing the system toward fatal gridlock. Debris in lower orbits eventually falls back and burns up in the atmosphere. But at higher altitudes, there is no air to slow it down, meaning a collision today leaves lethal shrapnel circling the planet for centuries. If the cascade continues unchecked, certain vital orbits will become so dense with flying shrapnel that launching anything through them safely becomes mathematically impossible. Future moon missions, Mars exploration, and even replacing our damaged communication networks would be grounded indefinitely. A mistake in orbital management made today could technologically lock future unborn generations out of space entirely. To prevent a total orbital lockout, a frantic global engineering race is currently underway to clean the sky. Researchers are developing tools that look like they belong in a science fiction film. They're testing space harpoons, robotic arms, magnetic capture nets, and even ground-based lasers designed to gently nudge debris back down into the atmosphere. We have to stop treating Earth's orbit as an infinite resource. It is a fragile, finite environment, just like our oceans, and it requires conservation. Every nation and company launching a rocket now carries a strict responsibility to ensure their spacecraft can be safely disposed of when its mission ends. Before humanity can colonize Mars or reach the stars, we first have to prove that we can manage our own technological footprint without locking the door from the inside. Do you think we will deploy these cleanup solutions in time, or is the chain reaction already too far gone? Let us know your thoughts in the comments below, and make sure to subscribe for more hidden stories shaping our world.